Can you hear me?
Yes.
Okay, yeah, wow, thank you for that introduction. I'm really excited to be here. Like Fariba had mentioned, my name is Trina, and I'm here to talk to you guys about environmental engineering and all the things that you'll learn in environmental engineering if you choose it, and go through the design process. So even though, Fariba, you had done your treaty acknowledgement, I want to do my treaty acknowledgement as well. So today we gather virtually on treaty number 1 territory, which is the original lands of the Anishinaabe, Cree, Ojai Cree, Dakota, and Dene people, and on the homeland of the Métis Nation. We respect the treaties that are made on these territories. We acknowledge the harms and mistakes of the past, and we dedicate ourselves to move forward in partnership with Indigenous communities in a spirit of reconciliation and collaboration. So before I get into my presentation, I just want to give you guys all a little background on who I am and, who I was in high school. So I wasn't, super into physics and math. I was really into sports. I went to Sisler High School. I loved rugby. I was a major environmental activist. And I really enjoyed teamwork, and I thought that, because of all these qualities, I might make a good biosystems engineering student. I'm in my last year of my studies, and I start as an environmental engineer in May. So it's just a little bit about who I am. So here's a little presentation outline that I have. So I'm going to first talk about what and why engineering, give you a little background on it. I'm going to go over the biosystems environmental engineering program. I'm going to talk about UMearth, which is a student group that I'm heavily involved with. I'm going to go over the engineering design process and then apply that design process to an actual design challenge, which will then be used as a guideline for your interactive activity. So a lot of information here, but yeah, I'm excited to share it all. So first of all, what is engineering? I'm going to give you a very broad general term of what engineering is. It is the application of science and math and teamwork to solve everyday world issues, worldwide problems with technology and design. So that's kind of a general term of what engineering is. And so why engineering? So I have this slide right now to kind of give you 3 main reasons why I chose engineering and 3 main reasons why I think are good reasons to choose engineering. So if you like teamwork, engineering is a lot of working in a team to solve a project together. If you are passionate about helping people, engineering does a lot with design that helps get people to meet their needs. So it's great if you want to help people. And lastly, if you enjoy problem solving, you'll see throughout this presentation that engineering really can be used to analyze a situation and figure out what the problem is and come up with a solution to problem solving. So I really liked riddles when I was a kid, and so that also contributed to why I chose engineering. And before I move on, I really want to highlight, if you're in high school right now and you're not too comfortable with your physics skills, or you're not too comfortable with your math, don't worry. You do not have to be a physics expert to be an engineer. When I was in high school, I took grade 12 physics 3 times before I got a good enough grade to get into direct entry. So don't let the physics-ness of it scare you off. You don't need to be great at it to succeed. So the reason why I kind of went over why I chose engineering and what's important in engineering is because I really wanted to tell you guys about the kinds of skills you would develop if you chose the Biosystems Environmental Engineering program. And so the 3 skills that I think are essential and very important when you learn throughout this process is project management. So what project management does in this environmental engineering program is it teaches you how to start a project and see it to completion while delegating tasks to your different group members. Then the next skill, communication, teamwork. Not only do you learn how to, see a project start to finish, but you also learn how to effectively communicate with your team and really build positive relationships in your team. Because at the end of the day, it's not just about completing a design. We also want to make sure that while we're working on a design, we work on it in a really like positive and collaborative effort. And lastly, as I said, problem solving. Going through this program, you would learn how to solve problems. And the reason why you would learn this is because in engineering, you're taught how to identify what the problem is. So you're able to, look at a big situation and see where the problem is, define why it is a problem, and then narrow in and focus on solving it. So yeah, just a little background of kinds of skills that you develop going through engineering. So now a little bit about the program itself. If you are interested in pursuing something like this, the admissions process is, it's pretty basic. There's 2 ways to get into the program. One, you can either apply for direct entry right out of high school, or 2, you can apply for University 1, and then while in University 1, you can sign up for first-year general engineering courses. If you choose a direct entry route, your grades have to be a certain average, but if you just choose University 1, that your grades don't have to be an average at all. You just might not be able to sign up for certain courses because they might be full by the time you get a chance to set up. But they're still both pretty good. So either or, you'll enter, you'll get involved with the program. Then in your second year, after taking, first year general engineering courses, you can apply for your department. So the types of departments are mechanical, civil, electrical, computer, and biosystems. I chose biosystems. And then once you choose like a certain department that you want, you can then choose a specialization in your department. So I chose biosystems, and then the specialization I chose was environmental engineering. And now I market myself as an environmental engineer. So I wanted to talk just a little bit of the kinds of courses that you do in environmental engineering, and what those design courses look like. So one of the ones that I want to highlight is water and wastewater treatment plants. So if you choose environmental engineering, you can learn how to design a water and wastewater treatment plant. And I think that is so important because not everybody in society has access to clean drinking water. And we need people who are able to understand how we treat water and how we get water to people so that they can meet their basic needs. Another cool design course that you take in this program is remediation. So that looks at, identifying a park or an area in a park that's been contaminated with oil, and then figuring out how to remediate that, that area. So how to clean the oil out of that area so that, an ecosystem can be there again, plants can grow there again, and that area can be reused. And so remediation is a huge part of what environmental engineers do in Manitoba because we've had quite a few oil spills. Another few things, you can learn how to design air pollution systems. So that looks at looking at a contaminant in the air and how to filter it out. Some of my friends with this course, they learned how to take excess carbon dioxide out of the air and back into plants, that's called carbon sequestration. That is very important for the future when we need to get our greenhouse gas emissions negative to solve the climate crisis. And then there's other things like ecosystem management. That's actually one of the electives I took. It's an interdisciplinary one. You can work with students outside of engineering to identify a problem in an ecosystem and work together to solve it. And then lastly, I put in here thesis projects. So what a thesis project is it's your final year graduation project, and that can be on any topic that you want. So I'm very passionate about solving really any environmental challenge in our communities. And so my thesis project was on assessing the current plastic recycling system in Manitoba and then proposing changes to each stage of the recycling process to, mitigate our environmental impact. So that is a little bit about the courses that are available to you. And so the next thing that I want to talk about was UMERTH. So UMERTH stands for the University of Manitoba Efficient and Renewable Technology Hub. This is the group that I'm very involved with. It's founded by engineering students, but it's an interdisciplinary group, meaning we really look to work on projects and initiatives with students outside engineering. We volunteer, we work on design projects, and we host events, all with sustainability in mind and all for the community. So Amar's philosophy, and so I hope I really sell this philosophy to you guys so that if you do go to university, you choose to sign up for this group. Our philosophy is to bring students pursuing different degrees together to solve sustainable challenges. And the reason that that's our philosophy is because engineers are great at problem solving. We're great at learning how to design different technologies to help the environment. But to solve sustainable challenges, we really need big groups of people coming together with different knowledge backgrounds and helping one another out to really have a holistic approach to solving, sustainable challenges. And with that being said, here's a couple of things that Unearth has worked on in the past. And, these are just a couple of ideas to give you, like, in case you wanted to join Unearth. If you did join Unearth, you could sign up and be a part of one of these design projects, or you could sign up and be a part of one of these volunteer initiatives or speaker series. And it's a great way for you to really learn how to apply, technical skills in design. And so one of the examples, we did a green wall design project. That's this picture over here. What we did is we learned how to create an automated system to water these plants on this wall. And then we hung that wall up in the engineering faculty. And so there's no maintenance required because it's just continuously watered and maintained on its own. We also worked with Festival du Voyageur. That's a picture of our team all working together. We did an energy efficiency study. So we soldered a bunch of components on these Arduino boards. And with that, we measured temperature throughout all the different tents in Festival du Voyageur to figure out where their heat loss was coming from in order to give them solutions on how to mitigate that heat loss. A few other things, we designed a solar canopy for the University of Manitoba. And that's to diversify the university's energy supply so that it relies more on renewable energy instead of, just hydroelectricity. And then, we've also volunteered for Habitat for Humanity. We've built houses for this program. We've also hosted, sustainability speaker series. So we've brought in professionals to talk about how to design buildings that are more resilient and that have a lesser impact of greenhouse gas emissions on the environment. So yeah, so that's a little bit about Unearth, what we've done, just to give you an idea in case you want to join it when you start university. Okay, so I talked a lot about engineering and problem solving. I talked about project management, but I didn't really explain yet on how we problem solve. So how we problem solve and how we manage projects and are able to be successful with our projects is through this design process. So if you choose engineering, you will learn this design process and you will apply it constantly to different projects that you're given. So it's a 6-step process. It's an iterative process, meaning that you do it again and again and again to make sure that your design is working. And like I said, it's what we use to solve challenges. So the first step is to define the problem. I talked a bit about that, seeing what the actual problem is in a situation and stating your team's objectives. So objectives are what your team actually wants to do. Then the next step is research, so collecting all the information relative to that problem. Then after your team researches, you come together to brainstorm solutions. And then after you've done some brainstorming together, you actually pick a solution and you create a design from that solution. So you might do something in actual school, you might actually create a prototype, or you might just develop, a drawing of a design and something that would be used in the future. Then you evaluate that design, so you test it, and then you go to refining it. So that means you look at what the problem statement was at the beginning, you look at what you said you wanted to do, and now you evaluate whether or not you actually did that. So yeah, so that's a little bit about the engineering design process. And so now I'm going to show you guys how you would use that design process to solve a challenge. So I have here a picture of Northwood Community Center. I'm not sure if anybody lives in the area. Northwood Community Center is not actually doing this design challenge. It's just the community center I'm most familiar with since I grew up in this neighborhood. Um, but so I want to give you an example of like a theoretical design challenge. So what if Northwood Community Center came to you and they said, we want to lower the community center's greenhouse gas footprint from heating using a $70,000 budget. What should we do? Well, that's a big topic. I don't know what they should do. I don't know how to solve that problem, and I don't know what the best solution would be moving forward. So, but given this information, we can now apply the design process to figure that out. So what we first would do is, like I said at the beginning, is define the problem. And everybody pay attention to this design challenge example, because for the interactive activity, you're going to be doing a design challenge in groups. So pay attention to what these steps are and what you do for all of these steps, because you'll need it for the interactive activity. Sorry, I didn't mention that at the beginning. Okay, so your first step is to define the problem. So based off the information that, let's say, Northwood Community Center gave us, the problem is actually already pretty defined. We know they want to lower their greenhouse gas emissions, and we know they have $70,000. So the first thing that you would do is you would just write that all out in one statement of what your team needs to do. So I wrote the problem statement as, you know, the community center needs to reduce its greenhouse gas emissions from heating. Our job is to find a solution using $70,000 that either reduces energy demand or uses renewable energy instead. And so what I kind of did here is I stated, you know, two different objectives of what our solution would be. So our solution is what our solution is going to do. So our solution is either going to reduce energy demand or it's going to use renewable energy instead, because both of those, you know, objectives would lower the greenhouse gas emissions from heating. So your next step would be to research. So if I was given this problem, you know, there's kind of 4 different areas that I would research before I move on to the next step. So the first thing is I would research the type of heating system that the community center uses. So what do they use for heating right now? Why isn't it working? How efficient is their heating system? Where's like the biggest flaw, you know, in the heating system that's creating the most waste? I would do that type of research first. Then I would research different technologies that reduce heating demand. So are there things like better insulation for the building? If there's better insulation, then, you know, the building wouldn't need as much heat to keep warm because it's better insulated. So, you know, like less heat would be escaping the building, so maybe they wouldn't need as much energy. Maybe there's something like better thermostats, you know, like that could be a flaw in their heating system if they might be overheating some places and they don't know it because their thermostats aren't working properly. The next type of thing that I would research are new renewable heating technologies. So I'm not sure how familiar you guys are with the different types of renewable energy heatings there are, but there's quite a few actually that can replace what we currently use to heat our buildings. So currently, most buildings use, you know, natural gas, and natural gas is a raw material. And so with that being said, when we burn natural gas, we create a lot of greenhouse gas emissions. What we could do instead is we could research a geothermal energy boiler. Would something geothermal work instead? You know, geothermal relies on the actual heat within the earth heating up water and then transmitting that heated water all throughout the building. Or we could look at biomass. So if biomass is used from, you know, agricultural waste, or if it's used from a forest that's sustainably managed and close by, then we could potentially use biomass to replace the natural gas heating. But yeah, so just another example of something that I would research. Then lastly, I would probably do some research on what other community centers are doing. You know, maybe there's something that I'm not even thinking of. Maybe someplace in Europe has this really cool micro heater that is just very efficient and works really well and has a new type of renewable energy, you know? I don't know if it does, but maybe, but that's all part what the research stage does. And so I guess the point that I'm just trying to make with this slide is when it comes after you've defined the problem, your next step is to try to do as much research as you can on it. Okay, so then your third step would be to brainstorm solutions. So an example of brainstorming could be, you know, you guys have a group of 5 people. You have one person who's writing down ideas, and everybody contributes as many ideas as you can. And in a brainstorm session, you're always taught that no idea, no solution proposed is bad. And that is really true. Anything goes in a brainstorm session. Even if you're a shy person and you think that maybe your idea doesn't make sense, just say it anyways, because the worst thing that could happen is your idea doesn't get picked. But what's really important in engineering is it's a team sport. It doesn't matter whose idea gets picked. What matters is everybody contributes and everybody is heard. And even the solutions that aren't picked, maybe they help you think of things that you wouldn't have thought of before. So in a brainstorm session, I would recommend, especially like in your interactive activity, if you get together with your group, you have one person with a pencil and you have everybody, kind of saying what kinds of solutions they think you could implement and you could have. So yeah, so that would be your third step. Then your fourth step, it would be to pick a solution. So in my example of this design challenge that I've given, I have said, our team came together, we did all the research, we did all the brainstorming. This is all theoretical, by the way. My team didn't actually do this, but let's say that we did. We then decided that, with a $70,000 budget, we can't put in insulation everywhere within the building. Or, with a $70,000 budget, we can't use geothermal because it's too expensive and the labor cost it's going to be too much. So with a $70,000 budget, we thought, maybe you can't replace the entire heating system from natural gas to biomass, but you could maybe replace like a small little amount of it. So in our theoretical solution, we have suggested to the client that we recommend you implementing a very small scale biomass heater to help reduce the load that the natural gas has to have in heating up the entire building. Sorry, I'm just checking my phone for time. So that's kind of it for my presentation. I think I saved us 2 minutes. So I'm very, happy to answer any questions, especially I think I may have missed what types of careers would be available to you with an environmental engineering degree. So if anyone's interested in that, I can touch on that a bit as well. But other than that, I do have the interactive activity, the design challenge ready for you all. And so should I go over the interactive challenge right now, or should we do questions?
We can do questions at the end. And if anyone has questions, they can send it to me in the chat or just in the chat.
Okay, perfect.
So stop recording now because we're starting the activity.
Okay, perfect.